Hello, hello, testing. Hopefully my mic is not peaking. Hello, hello. Bam, it's Leetcoding time. Hello, good morning, or afternoon, evening, wherever you are. We're trying a Google interview question today. My brother actually recommended this question to me because he's studying for job interviews too. Let me get my Chrome window up. Okay, there we go. Okay, there we go. Yeah, so I've been, I don't know, about 2 hours ago, I was discussing this problem with my brother, so I may have a head start on this. Let me resize so you guys can see it. Okay, that's probably fine. Okay. Okay. Leetcode 1146 snapshot array. Implement a snapshot array that supports the following interface. Snapshot array int length, that's the constructor, initializes an array-like data structure. With the given length, initially each element equals 0. Okay, that's fine so far. By the way, I was told that, excuse me, the solution might involve the use of a tree map. I have no idea how it comes into play or why we would need it, but I'm sure I will soon find out. Void set index, comma value sets the element at the given index to be equal to the value. Okay. Int snap takes a snapshot of the array and returns the snap ID, the total number of times we call snap minus 1. Okay, so that makes sense because they start at index 0, right? Sure. Int get index comma snap ID returns the value of the given index at the time we took the snapshot with the given snap ID. Okay, so our job is to kind of implement a sort of array list like structure, except we can take snapshots or like checkpoints during different points in time. We can take, the user can call snap to take a snapshot or take a checkpoint, and then each checkpoint is given a index 0 through whatever, and then we can be like get index blah from checkpoint or snapshot blah. I see. I think it would be helpful to load this into Sumo Paint. Okay, Sumo Paint is here. So my initial thought would be to use a 2D array. Yeah. But we're only storing ints, right? So int would be a 2D array like that. I think the rows would be, that is a huge arrow. The rows would be the snapshots, right? Snapshots like 0 through whatever. And then the rows would actually be like the arrays, like blah. Yeah, so index 0 would be the array at snapshot blah. Index 1 would be the array at snapshot blah. I mean, I'm pretty sure this would work, right? And what will be the runtime of this? Initializes an array data structure. Initially, each element equals 0. That should be all one time. The default value for arrays is 0, right? For Java. Set index comma value sets the element of the given index to be equal to the value. I guess at this point you would take the last snapshot. Yeah, the last snapshot. So you would take, yeah, it's just a 2D array set, right? Int last snapshot index and the actual index equals value. That's like one time amortized, I think. Snap takes a snapshot of the current array and returns a snap ID. So you would duplicate your current array, right? Yeah, you just duplicate your current array, and then your snapshot is stored at the current old index it was at, and then the next time you set indices, you would set it at the newest index. Yeah, I feel like that's it, right? And then get is just a 2D array fetch. All right. I was told that this would involve tree sets or tree maps. So I'm pretty sure my solution right now would be too slow, maybe, or be like, I don't know, memory limit exceeded, probably. But I still want to, for the sake of it, just implement this simpler solution, and then we can try, you know, whatever optimization we need based on whatever error messages we get. Yeah, so okay, let's go for this 2D array method for now, and then if we run into issues, we can optimize it with other data structures. Okay, so let's go. Int length initializes an array-like data structure with a given length. Okay, so this would be, we would probably need to store like a public, or not a public, just like a, should we do an array or a list? This seems really simple, right? It should just be a list. Fortune says, yo ho, it's a talking car here. Oh, hi Fortuner, how you doing? I'm trying a Google interview question. Oh, scary stuff. Okay, let's do a 2D array for now. Int 2D array is equal to, let's call this snaps, is equal to, well, let's not initialize it yet. So snaps would be equal to new 2D array, int the length. Wait, no, hold on. Oh, okay. It might be more convenient to use a list actually, since how do I say this? Its length is dynamic. If we do a array, the more we snap, we might run into problems of, you know, running out of indices to use. So I think it would be a better decision to use a list of lists. Yeah. A list of integer. Okay. Yeah, because otherwise I would have to, yeah, if I run out of space in my first layer array, that would be kind of a hassle. I would have to double, or yeah, I would have to copy over all my stuff into another bigger array, wouldn't it? Wait, ChatGPT, help me, please. Java, how to make array size dynamic or unlimited. Bars says, any advice for a beginner who knows a decent amount of dev, but not data structures at problem solving in general? I would say just start. Start with the easy problems first on Leetcode, if you're asking about Leetcode. There's this list called the blind 75 questions. Yeah, this thing, blind 75 Leetcode questions. People say that if you kind of nail this down, don't do the binary stuff because you never see those in interviews. But if you kind of nail this list down, you should be like pretty set for most interviews, unless you're interviewing at like super hard companies like FANG companies. Yeah, maybe start from here. These are like the more basic, easier questions. Yeah, start easy and then work your way up to medium and the hard questions. Yeah. Good luck, man. Okay, so snaps is going to be a new array list now. And then in snaps, we're going to initialize a new array list with the given length, right? Do we need to save the length? Because if they try to insert a length, an index that exceeds the length, do we have to return some sort of error or something? Hold on, I have a stupid question to ask ChatGPT. Can you store a list of arrays in Java? Bar says, thank you, also cute avatar. Oh, thank you. You can store a list of arrays in Java? That's a thing? Okay, well that's what I'm doing then. It will automatically like throw errors if you try to add indices that are out of bounds. Okay, that's my strat then. So we're gonna put a list of int arrays. Wait, that's a thing. I didn't even know this was a thing. List of int. Dang, okay. Darsha says, where are you from? I'm from USA, the west side of USA. Where are you all from? New array list, and then we're going to add a new initial int into array list. So snaps dot add new int, and then initialize it with length. That should be it, right? Bar says, I'm from Singapore, from India. Wow. People from all over the world here. Hello. How do you say hello in India, or what language do people speak in Singapore? Chinese? Ni hao ma. Do they speak English? Chinese? They speak English. Oh, wait. Some sort of Chinese, Malaysian, English, Mandarin. We speak English in Singapore. Oh. Well, hello. Okay, should we do some sort of sanity check here? I don't even have confidence that I did the constructor right. Maybe we can just print out system.out.println snaps.get 0, and then do a little arrays.toString. Cool. This is not going to end well, but we don't have to return anything here, so just put a return. Let's put a bunch of bogus values here, so return -1, get will return -1. I just want to see the constructor print out like what it's initialized as. Like, is the default value even 0 for Java? I totally forgot. Let me see. Yeah, okay, perfect. The default, yeah, Java arrays default to 0, so we don't have to do anything. We don't have to like do an arrays.fill thing. Okay, that's perfect. Darsha says, I'm also doing Leetcode in another tab. Hey, let's go. Bar says, ha ha ha. I totally forgot what language Singapore is. Darsha said, I believe most in US do Leetcode in Python. Python is really good for Leetcoding, but my first ever job and the longest job I was at used Java, so I'm more confident in Java, I guess, though clearly I'm not like super good at it. Okay, so we got the constructor down. Nice. Now the setting part. Okay, how do we do the setting part? So we get the array from at the last index in snaps, right? And then we just put index equals value. That's pretty much it, right? Yeah, okay. So we do snaps.get the last index, which is snaps dot size minus 1, and then we do at the index is equal to value. Yeah. How do they test this? Snapshot array set 3, okay. Should I just return at the end here? I want to do a sanity check here again too. Let's just print out. Should we just print out what the value is at that index? System.out.println and then snaps.get. Last one with the index. Yeah, just as a sanity check. Maybe I add a inserted here. Sick. Okay, so what do we have here? We set 3. Uh-oh, snapshot array initialized with 3, that's good. Set 05, so inserted 5, good. Snap, we did not implement snap yet. Set 6 at 0, okay, that's fine. Okay, so I think our insertion is okay. Darsha says, where exactly in US, mate? Your accent screams the New York. Really? Really? I don't think this is New York accent at all. Wait, New York people don't speak like this. I can't imitate a New York accent, but I'm from California. Was that an okay thing to say? Yeah, you'll never find where I live. Californian people, I guess, are known to speak very slow, like they have bubblegum in their mouth, like, hello, do you want to go to Starbucks? Bro, dude. Fortunate God says, I'm from India. Yeah, there's some Indian people who often come here. Okay, so array, the constructor works, setting works. Let's work on snapping. So what we have to do is duplicate the array and then insert it back, add it back into the snaps, right? Okay, how do you duplicate an array in Java? Java, how to duplicate array. Clone? Is this a shallow thing or a deep thing? Dot copy of? Oh, okay. For object arrays, it copies the reference of shallow copy. Oh, it shouldn't matter for our case, right? Because we're just doing numbers. Arrays.copy of is arrays.copy of shallow copy. I'm just curious. I don't think it matters. Okay, it's shallow copy. I think I'll go with arrays.copy of because I'm used to using helper methods from arrays. It might be easier to memorize for me. Okay, so what we have to do here is snaps.add, and then we take the current last array and duplicate it. Snaps.get, probably that. Should I? Maybe for simplicity and organization, I'm gonna just put the copy in a whole nother variable. Is equal to snaps.get the last index, and then we do arrays.copy of and then snaps.add copy. What do we return here? The total takes a snapshot of the array and returns snap ID, the total number of times we call snap minus 1. So return the last index basically, right? So if you copy once, if you copy once, return 0, right? Oh. The total number of times you call snap minus 1. So yeah, if you call snap once, you return 0. Oh, but then at that point, you're going to have 2 arrays. So whatever the... I see, so the last index minus 2, right? Yeah, or the size minus 2. I think that's it. IBN says hi. Oh, hi, IBN. Welcome back. I remember you. How's it going? So you would return snaps.size minus 2. Okay, that's snap. Let's try this out. Oh, what's going on here? No suitable method found for copy of... Really? ChatGPT, you lied to me. Arrays.copy of? Lets you resize. Oh, is it because I have to specify a length? Okay, maybe clone is the best choice then. So snaps.get the last array dot clone. Okay, maybe this is the better choice. Oh wait, I forgot to even activate the function. Okay, well at least it runs now. So do we have a snap operation here? Snap. And the snap returns 0, which is good. Okay. Nice. Can we print out, like for sanity checking, what our sort of snaps looks like? What our 2D array looks like currently? I think that's a good idea. So for int I, can you do a for each loop with a list? Java for each loop with list. Oh, you can. Okay. That's very convenient. So int array snap in snaps, you print it out. System.out.println arrays.toString the snap. Run this thing. Okay, very good. Okay. So snapshot array, you set 05, so it becomes like this, okay? You snap with nothing and it becomes like that. Am I printing out this right? Snap. Oh, yeah, that makes sense. So snap, there would currently be two of the duplicate. And then when you set in the future, you would set on the latest one and then keep the previous one intact. Okay. This is good so far. And then get the index and the snap ID. So all we need to do is just make a 2D array get, right? So return snaps.get snap_id, snap_id, and then this will return a array, and then we would call index. Wow, look at that. Accepted. I is a genius. Although, I was discussing this problem with my brother earlier. If you do it this way, you'll probably get a time limit exceeded when you submit it. So yeah, that's my prediction. Time limit exceeded, here we go. And then we're gonna find some, yeah, memory limit exceeded. Oh, I was wrong. It's memory limit exceeded. Okay, this is fine though, because we have a better test case to test with. Okay. We need a better strategy for this. So clearly, storing a 2D array is not the optimal solution. what we have to do is, yeah, by the way, in case you're wondering, IBN says, I just finished today's Leetcode challenge with bit masking. Cool challenge, really? That sounds complicated. Bit masking. Was the problem like a binary problem? Bits? I'm not very good with those kind of problems. Okay, we need a better strategy for this. Can I take an eraser here? Oh, here's an eraser. Erase these people. Okay, so clearly storing a 2D array is not an option because it uses too much memory. Yeah, it kind of makes sense though, right? Because every time we insert an element, we duplicate the entire array, even though just one element changed. What if we can just store the differences? Yeah. If we snap, yeah, what if we could just store the differences? So let's say you have, they initialize this with 3, right? Okay, so I'm looking at example 1 over here. They initialize snapshot array with 3, so you would make a list like this with 3 spots. IBN says it's not that hard, it's just like an array of boolean to maximize if-else statement, to minimize if-else statement. Ooh, interesting. I still have no idea what that problem is. And then if you set 05, maybe instead of storing like numbers or an entire array here, we would just store keys that map the snapshot ID to the actual numbers, right? So over here in the first index, we would store something like, we're at the 0th snapshot, and then our current number is 5. Yeah. And then we would snap over here. Okay, snap. Maybe we should have a variable here that says like current snap to track which snap we're on. Snap is equal to 0 at first. Okay, so then that's how we know the key is 0, the snapshot ID, and then it maps to 5. Now when we do a snap, I think what we have to do is increment this to 1. So we increment our current snapshot. And then now when we set the 0th index to 6, we would now do 1 is mapped to 6. Yeah, okay. And then when we try getting 0, 0, so we're getting the 0th snapshot, the 0th index. So we would just, yeah, we would search into, what should we store here? Like a hash map? Yeah, hash map. We would take the hash map at index 0 and then find what the key 0 maps to, which is 5, and we would return that. This is starting to make sense. Okay. What happens if we try getting from here and we're like, okay, what's at the 0th snapshot? We have nothing here. If we have nothing, do we just return 0? Maybe that's the solution. The default is 0, right? Yeah, the default is 0. Okay. Wait, what happens if we, okay, I'm just thinking out loud here. What if we have like a, at the first index, the 0th snapshot maps to like 7 or something. And then we're like, okay, what's at the first snapshot? Oh, okay. Okay. I think I understand why my brother was saying this requires a tree set. So if we're trying to find the first snapshot at the first index here, like if we're trying to find the first index's value at the first snapshot, there's nothing here. So we would have to default to the bottom one, which is 0 to 7. How do tree maps work in Java? Tree maps Java. I was just looking this up, by the way. There's a function called lower entry. Is there a lower value? Lower entry. Maybe it's lower entry. Lower key. Returns the greatest key, strictly less than the given key. That's exactly what we need, right? That's exactly what we need. So if we're at the first index, first snapshot, but the current index doesn't have a first snapshot, we would have to return the first thing below it, like 0, right? Or null, there's no such key. Yeah, if it's null case, we would just return 0. We're onto something here. So the key is to use lower key. Yeah. Oh. Should I just write lower key here? Lower key. Okay. Yeah, I think we have a plan now, right? This totally would work. This will be my first time using tree maps in Java. Okay. Let's optimize this boy. So over here, we're going to have a list of tree maps instead of tree map integer instead of list of arrays. How do you make a tree map in Java? Is this tree map? Oh, it's integer to integer. Okay. There's two types, the key type and the value type. List of tree map, integer, snaps. Okay, so snapshot array. Snapped is equal to new array list, that's fine. And then snaps.add new int length. Can we set a limit on the tree map? Time to ask ChatGPT. In Java tree maps, can you set limit on max number of keys? Nope, it does not. Okay, we might have to check that later ourselves, but for simplicity, let's just do just a new tree map for now. New tree map and let it auto infer the types. Okay. For setting, how do you put stuff into tree map? Is it put? Just like hash maps put? Put, yeah, it's put. Okay. So we would do the tree map at the last index, which is this one, dot put, and you map the current snapshot ID. You would do current snap, comma, value. Set index, comma, value. Put, wait, am I doing this right? Put the current snapshot and the value. Wait, no. The list I would get, oh, the index I would have to map to the list. The index is for the list. So snaps.get the current index. Yeah, and then that index will return the tree map associated with that index, and then we would put current snap, comma, value, which reminds me I have to track the current snap. So int current snap, okay, and then current snap should be initialized to 0 at first. Okay, that should be it for this. What happens when we snap? We need to increment our current snap, right? That should be it. So current snap plus plus. Our current snap defaults to 0, right? So maybe we just return current snap minus 1. Yeah, so current snap defaults to 0. If we add snap, it would increment to 1. Yeah, and then we would return -1 of that. You know, I could just do a return current snap plus plus, because plus plus is an operation that takes place afterwards, right? But I think this is clear. And I'm forgetting, this is the tricky part. Well, it's tricky in the sense that I haven't used tree maps before, but let's do, what should we call this variable for the key? Best key is equal to snaps at the current index, right? Index dot, what was the method again? I wrote it here, lower key lower key equals what? The snap ID, no, the index, right? Or the snap ID? Snap ID. Yeah. Yeah, we're looking for snap ID. If we're searching for 1 here, we would default to 0, the lower one. Okay. Is it allowed for... What happens if you try in like assigning a null to an int? Let me ask ChatGPT. Java, what happens if you assign null to int? IBN says 0. Oh, it'll give you a compile time error. Okay. Maybe the choice is to use integer because we would be able to tolerate nulls, and we would be able to check for nulls in the future. So integer best key is equal to this. So if best key is equal to null, then we will return 0. Yeah. IBN says 0 maybe. Yeah, we will return 0 here. You were right on that. And then else, we would actually... That means there's a key that's lower than us, so we can get the key. So then you would return snaps.get you would get the index, right? Get the index. Dot. What's the method to? What's the method to get the value? Is it? I think for hash map it's like get. Is it get? Yeah, it's get. Okay. Dot get the best key. Also, I realize I've been interchanging list and array syntax. So snaps.getIndex should be here. Is there elsewhere where I mix those up? .get. Okay, this should be it. This should be it. Let me read through my code one more time to make sure it actually makes sense. So we initialize a list of tree maps. Okay, that maps the let me make this more clear. List index is equal to the actual array index. And then tree map, the key is equal to snap. And then value is equal to, the actual value. Okay, list of tree map integer to integer. Yeah, that makes sense. Current snap, good. Snaps is equal to new array list. Yes. Snaps.add new tree map. Okay. Current snap begins at 0. Makes sense. Set snaps.get index, which is the current index, dot put. In the tree map, you would add the current snap and the value. Okay. And then you would return Elemental Magic's card game. Ooh, hello. Is that a Yu-Gi-Oh inspired name? The Elemental Heroes? It is not? Oh, what is it inspired by? Magic the Gathering? Hearthstone? I don't play either of those games. Okay, and then snap, you would just increment current snap plus, and then return current snap -1. That should make sense. For get, you would determine your best key by snaps.get index, which gets the current tree map at the current index. Dot lower key snap ID, which gets your best key. If best key is equal to null, you return 0 because you have nothing there. Else, you definitely have a key at this point, and you would get snaps.get index to get the tree set again, .get best key. Elemental says originally Altail, although that game no longer exists. Oh, that's really sad. You must be all for the... What was that game that campaign that Pirate Software doesn't like? Is it the Fix Games campaign? I forgot what that campaign is called, but you must be really for that campaign. The Save Games campaign? Hold on. Pirate Software Save the Games campaign. Oh, Stop Killing Games. Yeah, there was this whole movement that people were signing signatures for, where they wanted developers, like big game companies, to sort of have a end roadmap when they're like closing games or shutting down games. They wanted to have a plan for the gaming companies to have a plan, either like give the source code to the people so they can sustain it themselves, or like have just any sort of plan when they're planning to shut down games. Yeah. It's a good idea, right? Especially, it's just really sad when a game you like just shuts down. I don't play too much games, so fortunately that hasn't happened to me. Oh wait, there was a time when Club Penguin shut down, right? And everyone was really sad. I was part of you were part of the team that made Magic Spell Slingers. It was a game by Wizards of the Coast, but after a few years they nuked the game from orbit and now it's all just gone. Oh, that's really sad. Well, stop killing games, am I right? Okay, I just realized a really bad mistake here. Can you spot it? Very good, you spotted it. So we only have one tree map. We need multiple tree map for each index. Yeah, that's pretty bad. So we can do like a for int I is equal to 0, while I is less than length, I plus, and then snaps.add a new tree map at all those locations. We only need one, right? Yeah. Narration. They did not in fact spot it. I barely spotted it. Okay. Who bets that this... Oh, no. Oh, semicolon. I was gonna say, how much will you bet that this code runs? It clearly does not run. Compile error. Valley. Oh, I misspelled val. Uh oh, that's not good. Okay, so apparently I returned 5 here when we're supposed to return... No, I returned 0 here when we're supposed to return 5. Okay, how did that happen? We're doing 0, 0. Well, yeah, how did that happen? Time to debug. What's our alleged best key here? Actually, how do we set stuff here? Snaps.get, the current index, .put, current snap value, okay. Yeah, what's our best key here? Best key... System.out.println best key. not to be confused with best girl, is equal to best key. Elemental says, so I got an idea here. Ooh. Speak, what is the idea? Best key is null. Uh-oh, that's not good. Lower key snap ID. At this point, we should expect the 0th index to have 2 keys, no? Like 0, 5, 1, 6. Elemental says, my idea is this. We don't need to actually be able to do time traveling here because we only do IO once. What? So we can order the gets in increasing order and then just run the sets, outputting the gets at the appropriate time. Is that wrong? I'm a bit confused on what that means. We don't need to be able to actually do time traveling here because we only do IO once. I think we need to do time traveling because they can do a get. Well, the whole point here is you can have checkpoints, right? Like time traveling. Every time you call it the function snap, it takes a snapshot that you can go back to in time. It preserves that moment, that snapshot of the array in that moment in time. And then when you call get at the index, given a particular snap ID, it will actually be able to get it. So I think we do need to do time travel. Wait, but you're saying, but we know ahead of time what all the gets are. We know ahead of time what all the gets are. So we can output the value at the snapshots and then throw away the snapshot. I'm so confused what you're talking about. You might be onto something though, it's just that I don't understand what you're talking about. We can output. In other words, we just need one array of values. Wait, why? What about the example here where they input 05, take a snapshot, and then 06, and then try to get 05? What do you do there? Crimson Moon says, hi. Hello, hi. How you doing? Well, while Elemental is typing, I'm gonna do some debugging here. I think it's time to actually print out what my tree maps contain. What's the best way to print out what a tree map contains? So this will iterate through all my indices. My current tree map would be tree map integer, comma, integer. Current tree map is equal to snaps.get I, and then we would do print everything out. How do you do that? Is there a get keys thing? Key set. Okay. So for int key in t.keySet, and we print out what the key value pairs are. System.out.print and then I would print what? Key plus space plus t.get the current key. Okay. I would do a system.out.println tree map plus the index, and then we would do a little hey. Okay, let's try this. We say 0, wait, let me fix this. What is going on here? Dot out, dot println. T is equal to snaps.get. Wait, what's going on here? Plus I, oh, I see. Plus, we need a plus sign here. Elemental says, we say 0, 0 means get the 0th index of the 0th snap. Oh, you mean 2D array? Use a 2D array? We say, wait, get I, snap is redundant, just make it get I and move the command to be at the appropriate point in the input. I'm so confused. You might need to draw a diagram for this. This is I need a diagram to explain my own solution to myself. We say 0, 0 means get the 0th index of the 0th snap. Thus, we build this to an output buffer before we overwrite the 0th index from 0, 6. In other words, when we see 0, 0 in the input, we read that value before the first list. This is going way over my head. Output buffer? What? In other words, get I, 0 means put a get I right before the first snap. Get I, 1 means right before the second snap, etc. I'm so sorry, I have no idea what you're talking about. I can't see how this will get done with one array if you have to preserve history. Yeah, sorry about that. It's hard for me to understand your explanation. Well, your explanation is probably fine. It's just that my brain capacity is very limited. Oh, length is not a thing, so snaps dot length its size. Snaps dot size. Oh, we probably don't want the second case running then, if it's already output limit exceeded. Elemental here says, yeah, the idea is you don't have to preserve history. Okay, the idea of not preserving history is what's getting me. What? This problem is all about preserving history because you don't have to wait until after the fact. The get commands tell you exactly where in history they are asking, so you can just read them as they happen. This is probably so high level. Wait, you can just read them as they happen. Wait, that makes no sense to me. You can just read them as they happen, but they're not necessarily gonna call the get function as it happens. What? TreeMap 0 has 0, 5. TreeMap 1 then has nothing. TreeMap 1 has nothing? Oh, I know that makes sense actually. TreeMap 1 has nothing, TreeMap 2 has nothing. TreeMap 0 then has 0, 5, 1, 6. This is horrible formatting, but hey, I can still understand it. TreeMap 1 contains nothing, TreeMap 2 contains nothing. Okay, so it's the best key thing that's tripping us up. The best key is for some reason null. Like if you see a get index equals 5, snapshot equals 3, then when you are about to overwrite the third snapshot with the fourth snapshot, when you are about to overwrite the third snapshot with the fourth snapshot, you read index 5, and that's your output for that command. When you see get index 5 snapshot 3, when you are about to overwrite the third snapshot with the fourth snapshot, you read index 5, and that's your output for that command. Are you saying you just have one? You need to look forward and retrieve all the get commands. Oh wait, are you saying... I still don't think I completely understand what you're saying, but are you saying that we need one array to store... We need one array of length, and then we sort of delay our writes to this array. You have an array of commands, an array of values. Oh, okay. Oh, interesting. Okay, an array of commands, an array of values. That might work, actually. You then update values in order. So you're saying like we have an array of commands, an array of values. Maybe your commands are like 0, 5, 0, 6. So you begin like this, huh? So someone gets like, okay, what's snapshot 0, index 0? It's this. Okay, we're done with that. And then we put 0.5 here. No, 0.5, just like 5. And then someone says, okay, what's snapshot 1, index 0? This. Okay, we're done with that. Replace with 6. When a command is to take a snapshot, you output all the get commands for that snapshot. You output all the get commands for that snapshot. All the get commands for the snapshot that's about to get overwritten, that is. Okay. What if they want to get an older snapshot then? What happens in that case? But you've already overwritten it. Like what if after getting snapshot 5, they want to get snapshot 0? You're saying it's going to get overwritten, huh? What if you want to go back in time versus forward in time? Or are you saying that we store all of our commands perpetually? Before you do your first snapshot, you process all the get commands for snapshot 0. No such thing as out of order, that is. You know, Elemental, you might be way too smart for me. I'm getting so confused with your explanation. I thought I got it, but now I don't. You want to try this problem? Maybe you can let me know if your solution works. That would be pretty cool. Let me give an example, okay? Yeah, you might have to explain like what exactly are the data structures you're using. Like, at first you said you're using just one array, right? And then you started saying that you have to store the commands somehow, so that kind of confused me. Like what happens when you set, for example? What happens if you get? Okay, well, I'll be here. I'm here debugging. So I have a few clues here for my current solution. One is, so tree map 0, 05, tree map 0, 05, 16. So clearly our tree maps are updating correctly as I wanted it to. However, our best key is always null, which is wrong. We have snapshot 0 and 1 in index 0. So something's up with the way we get our lower key. What's wrong over here? Snaps.get index dot lower key snap ID. Are we not using this correctly? Dot lower key, return the greatest key, strictly less than the given key. Wait, it's strictly less. Oh. Oh, wait. If it's strictly less and we're getting 0, snap ID 0, 0. If we're getting 0, then there's no solution. There's nothing less than 0. Do we have to do snap ID plus 1? We got it! We got it! Oh my goodness. Let me comment all these out. Submit. Hopefully I didn't just comment something I needed out. Time limit exceeded. No. Where's the time? What? Time limit exceeded. Uh-oh, that's not good. Wait, what could be taking so long? So this is 50,000. Is it because we're instantiating tree maps for each index when we probably don't need to? Maybe that's it. Okay, let's get rid of these print statements here. We don't need them. Get rid of this print statement here. Maybe we only need to make a tree map when we really need to. Okay. So when we're setting over here, snaps.get list. Wait. Java how to check if list has element. If list of objects has element. Elemental Magic's card game. Oh my gosh, that is so much. Wait, hold on. I feel like my solution is really close, by the way, but I'll read this anyways to gain some insight. I'm just going to copy this here. Ho ho ho. Set 03, set 05, set... Okay, that's the example. First, we build an array of values, 0 through 0. In addition to our array of commands... You really need a whiteboard, lol. In addition to our array of commands, we then process... In addition to our array of commands... Oh, we're literally storing this? First, we build... Oh, no, this is the input, huh? First, we build an array of values from 0 to 0, depending on the length, okay? In addition to our array of commands. The input is the commands, yes, okay. We then process the sets, giving us 5, 10, blah, blah, blah. Hold on. You said 0 to 3, 0 to 5, 1 to 10, snapshot, 0 to 3. Okay, I see. 5, 10, okay. Then we have a snapshot. Okay, this means we run the get commands, which have snap 0. This means we run the get commands, which have a snap 0. Oh, that is get 0, 0 and get 1, 0. Then we take the snapshot. Then we run set 03, which gives us 3, 10, 0, and finally we run our set command for the last snapshot. We then have a snapshot. This means we run the get commands, which have snap 0. that is get 00 and get 10. Oh. Oh. I see, I see. So you're assuming that we have this, like this input. You're assuming we have access like to this list of inputs, huh? So then we would build our, so you're saying we would build our array, and then when we get to a snapshot, I see. So you're saying we would kind of build it and then return as necessary, like sort of process all the gets and sets in order. We then process the sets, giving us, okay, we run set 03, which gives us 3. Finally, run our set command for the last snapshot. So before we take the n snapshot, run on the gets, which have snap equals n. I see, so we selectively, I see what you're saying, okay. Yeah, I think your solution does work if we have the list of all the inputs in the beginning. But the trouble is, we don't have that. Like, there's no way in my code over here that has access to this giant list of inputs. This is only available to the test runner. So we can't selectively choose which gets to process at any given time. It's up to, so the test runner will absolutely run all these commands in order. So you have to kind of preserve history. Yeah, I see. I think that's where the confusion came from. You and I assumed different input sets. So your solution absolutely works if the input set is actually this. But this is only visible to the test runner. Yeah, I think that's why I was so confused. Like, but yeah. If this was the actual input you received to the object, to this snapshot array, this would absolutely work. That's actually pretty smart. Yeah. Well, nice thinking. I'm glad we cleared it up. Very interesting. I like. Yeah, Leetcode does do this. The inputs that they give here is not necessarily the input that they give you. Like for this problem, we're just given this. Yeah. Very interesting solution though. Also, wait, did my solution just get accepted? Or did it just get time limit exceeded? Oh yeah. We were saying that we only need to make a tree set if we really need to, right? Java had to check if list of objects has element at particular index. Except on sample input at least. Yep, that's a start. List.size. Wait, list default elements for get if list of elements, and I haven't put an element there yet. Wait, would it be a better idea to change this list to an array then? Arrays do have a default thing. See, if I don't add any tree sets in the beginning, then this list size will just be 0, right? Or whatever, how it's implemented, whatever small number it's implemented in the first place. If I do an array, I can actually check for a default value. Ooh, okay. So in our quest to dynamically implement an array of tree maps. Elemental Sizzle, by the way, want to know a Leetcode trick? Sure, spill it. Wait, you can't store an array of an object, can you? No. Java, can you store array of objects? Wait, you can? Holy crap, I'm dumb. Yeah, you can. Okay. Can you do a array of tree maps? Can you actually do that? The input data is actually visible to you, so the waiting times for a lot of problems involve scraping the starter code and just reading out the full input. Often this breaks the requirements of the problem, but they don't have a way to stop it. Oh yeah, I've seen that before. That's pretty funny whenever they do it. How to make array of tree set? Tree map? I think it's so funny they can do this. Okay. Tree map, integer. Okay, time to make another whole restructuring thing. An array of tree maps. Snaps. Okay. Oh, okay. Time for big brain time. Public snapshot array in length. Snaps is equal to new int wait tree map integer comma integer, and then we put length, right? Is that how you make a new list? Yeah, that's how you make a new list. Okay. Yes. For I equals 0. Okay, we don't need this anymore. We only make the tree maps when we really need to. Current snap is equal to 0 when you set. Okay. So we need to check if that index actually has a tree map. If it doesn't, we make a new tree map. So if snaps index is equal to null, then we input a new tree map there. So snaps index is equal to new tree map. So my approach technically could be used, but it's not the point of the problem. Oh. Yeah, if you really wanted to game the system, I suppose you could go that way. So you're a Leetcode gamer, huh? It feels like speedrunning when you do that. In a way, it's kind of respectable, though that's not how I want to do it. Is equal to new tree map, okay. So snaps dot, we can do bracket notation here now. Index, snaps index dot put, yeah, dot put current snap code value. And then what are we doing here? For every int I is equal to 0. Wait, what are we doing here? Oh, we're printing out stuff. Is that why it was so slow? Okay. It's okay, I'm already on this route. Elemental says I was into competitive programming back in college. Ooh. What sort of competitions did you do? Okay, let me read this out loud first. So if the current snaps index is equal to null, then you put an actual tree map there. Snaps index, which is the actual tree map, dot put current snap, comma, value, and you return. Yeah. Int snap, current snap plus plus, return snap minus 1. Yes, good. Inter and intra university. I never really participated in those. I actually did not know that was a thing. Hold on. Inter and intra university competitive programming. Wow, it's a thing. What are like some sample problems? I've got some pretty big contest victories, but also I've gotten stuck on problems and been roughly stomped at times. It's very hit or miss. Ooh, I feel like Leetcode is like that too, which is why for now I'm sticking to the easier or medium problems. At least for this problem, I'm always moving forward. Like, I get better and better with the solutions. Okay, over here. Index best key is equal to snaps. This is bracket notation again. Oh, we have to check if the index if we actually have a tree map there, huh? So if snaps index is equal to null, then you return freaking 0. Else your best key would be snaps index dot lower key. That should guarantee a tree map at this point. Dot lower key snap id plus 1. If best key is equal to null, return 0. Oh, this case would never come back then. Would it? You're pretty much guaranteed, every time you have a tree map, you're guaranteed to have a value in it, right? So delete this part and then return snaps.get index dot get best key. Run this boy. Line 7. Snaps is equal to new tree map length generic array creation. What's wrong with this? New Wait, what's wrong with that? New tree map integer length? Cannot create array with, ChatGPT, I thought you said you could. I thought you said you can make an array of tree maps. ChatGPT, did you lie to me? Tree map. New tree map 3. Oh, you don't even put the types there? Okay. Is that how it works? Okay, it got past it. Now we're at line 29. Return snaps to, oh, it's bracket notation. Let's go, it worked. No, what's null pointer exception? Where? Line 29? 29 here. Get best key. Wait, how? Wait, so snaps index is pretty much guaranteed to be not null, right? So is it the .get best key that's throwing us off? Oh, Are we storing null in here somehow? Let's use this test case. This is really weird. Use test case. Null pointer exception. This is very weird. Snaps index lower key. So we're pretty much guaranteed that snaps index is not null. Snaps index. So it's the value that's... What? That is so weird to me. Snaps index get best key. Okay, let's print out. It's time to do some debugging. ln let's print out the index space plus snap underscore ID plus maybe this. And let's print out the best key. Is that gonna help us? Let's just try this out. Question, if you have a value at index I for snap n, is this propagated to index I and snap n plus 1? Wait, let me read that again. If you have a value at index I, like the tree map, if you have a value at index I for snap n, is this propagated to index I and snap n plus 1? Oh, no, it's not. I'm relying on the lower key method here. So if you try to get a snap ID that's like non-existent yet in the tree map, then you would get the lowest key, the first lower key to it, like the first key below it. First snap ID that's below it, yeah. So standard out is this. We're getting index 1, snap 0. 1, snap 0. Ooh, this is getting hard to debug. Is this because we have some bad... Wait. What is default value for arrays of objects? It's null, right? Am I making a bad assumption here? Is null, okay. Okay, so snapshot array, you instantiate with 2. You automatically take a snapshot. Oh, interesting. So there's no tree maps here. 0. 0. What? I'm on PC now? Oh, hey, Fortuner. And you would get 1, 0. Oh, which is this one? Okay. Oh, interesting. But yeah, so we should be doing snaps. Interesting. So we try to get an object before we even put anything in it. So if snaps index is equals to null, return 0. This should be kicking in, right? Why isn't this kicking in? Snaps index. Can I print out what my... You know what? Let's print out what our snaps looks like. System.out.println arrays.toString snaps. Is it actually all null? Oh, interesting. What is this? Well, at least it prints out prettily. Snaps null, comma 1 equals 8. Wait, so it's this one right here? Oh, I see, I see. So for the first get, we're correcting returning 0, I think. And then we're doing another get 0, 0. Okay, and then we're doing a set 1 equals 8. And then we're doing a get on 1, 0 again. So what is it going to do here? Snaps index at 1, index 1, which is here, the 1 equals to 8 thing. Get best key. Wait, it thinks the best key is nothing. Snap ID is the second number, right? 1, 0. Wait, I'm getting confused, so... Yeah, we're definitely getting from here. And the current snaps looks like this. So what do we do here? We see snaps 0, Is it equal to null? Wait, snaps index. Index is the first number. So we first look at snaps. Snaps 1, is it equal to null? No, it's not, so we continue. Best key is equal to snaps index, snaps 1, $lower key, snap ID plus 1. Snaps ID is 0, so 1. Okay, and then apparently our best key is just null. Why is it null? That makes no sense to me. And then you return. Am I doing this wrong? Snaps index.get best key. Okay, at this point I'm kind of stumped. Why? Best key is null? Fortune says, anyway, I gotta go make a video on a version of Windows I found called Windows Experience Freestyle. Ooh, interesting. Are you gonna post it on your main channel? Are we not storing this right? Snap ID 1 equals 8. That sounds right. We do a snapshot here, so snap is now 1, and then we do 1 equals 8, at index 1 equals 8. Well, yeah, so it makes no sense to me why we're getting best key equals null. Is it time to consult ChatGPT? Last resort ChatGPT, okay. New chat. Yeah, I'm pretty stumped right now. I'll take any help I can get. Literally. I'll be posting it on the ClenTuner AC account, I see. This is the input. Yeah, I feel kind of bad for consulting ChatGPT this badly. This is the input. Why am I getting null pointer exception? Yeah, null pointer exception at this line, at this line, after getting 1, 0, 1, 0, after the first snapshot. Yeah, after putting 1, 8. Wait, after 1, after the second. The second, get 1, 0. ChatGPT, you're my last hope now. Oh, I see exactly what's happening. Your get method, best key, returns the largest key is strictly less than k or null. Your sequence of commands, snaps is equal to null, null, snap, current 1 is equal to 0, get 1, 0 checks snap 1 equals null, return 0, okay. Get 0, 0, check snap 0 equals null, return 0. Fortune says, alright, see ya, bye. See ya, good luck on that video. Set 1, 8, snaps 1 is equal to 0 to 8. I did this wrong. Our get method is wrong. Set 1 to 8. current snap is equal to 1 now. You are using the current snap equals 1 for set after snap, so the snapshot for this value is 1, not 0. For set, so the snapshot for this value is 1, not 0. Wait, are we not supposed to use 1 here? Snaps 1 only has 1 key 1 because you did 1, 8 after the first snap. There's no key 1. So best key is equal to null. You need to handle the case when lower key returns null. That means the value of that index was never set before the snapshot, so default to 0. But the answer shouldn't be 0, right? I don't think it should be 0. What's the expected value here? Oh, it doesn't say. Index 1. Oh. Index 1, snap 0. There is no 0. There is no snap ID 0. Snap ID, we only have snap ID 1. I see. Oh. I see. That was my bad, okay. So if best key is equal to null, return 0. That was confusing. Accepted. It's gonna say output limit exceeded, isn't it? Unless I delete these 2 lines. Output limit exceeded, yay. Do I have any other print statements? No, okay, submit this. Let's go. We did it. Oh, that took way too long. We've been at this for 1.5 hours, Jesus. I definitely have to review this problem, holy. Yeah, what was our problem? Yeah, we forgot to account for the fact that we could, we could store nothing for a snapshot. So we could take a snapshot with nothing in it, and then we could start inputting numbers into that index. So then when we try to get snapshot ID 0, even though we don't have snapshot 0, then we're kind of screwed. So we have to do a null check here. Oh, holy. It really pays to do null checking, huh? Alright. Damn. This was very Musakashi. Okay, I think I'll call it a day. Holy, this problem, man. I'll definitely have to do a review again sometime. Okay, thanks everyone for coming. Well, Sasuka Google interview question, huh? How long have we been streaming? 1 hour 40 minutes, dang. Just for one problem from Google. Okay, I'm gonna call it a day. Thanks everyone for coming. Mehak Walia says, you have a great day. Thank you. I appreciate. Thanks Mehak, thanks Fortuner. Thanks Elemental. I don't know if you're still here or not. Bye.